we do? Well, firstly, let's raise this power up. So we're integrating. We're going to have 2x to the power 6. And then we divide it by its power. Same thing, minus. What I will do, I'll put 4 on the bottom. So I'll have raising 3 and adding 1 to, we're going to have minus 2 over 4 times minus 2. And finally, 5, we're just sticking an x. And of course, we never forget the plus c. This is the one thing people should never forget. And thus, what do we do now? Now we just tidy up. So here we're going to have 2 over 6, so we're giving x to the power 6 over 3. Plus, because the 2 negatives, and the bottom half becomes 8. And of course, x minus 2. And let's just copy the rest. And that's it, guys. We conclude here. So when we differentiate this, let us firstly write this in the correct differential integration standard format. So without further ado, we should have y equals, and then root x we should know is always going to be x to the power half, so keep it always in indices format, plus and 4 over root x. So anything that's reciprocal that has a negative power, and because root x's power half is going to be 4x power of negative half, and of course we just stick in the plus 4. Now on differentiating this, what do we get? So dy over dx, first we drop the power half down, so we got half x and subtract by 1 is negative half. Drop the minus half to 2 against 4, so 4 times minus half is minus 2x, subtract by 1 is minus 3 over 2. And differentiating 4 is nada, nothing. Now, here they ask us to plug 8, x equals 8 into this dy dx. So dy over dx, when x equals 8, we should get. So before we do this, let's put this in the correct format. So put into the same format as the previous question itself. We should have 1 over 2 root x. Or in this case, instead of x, we're going to replace it with 8 minus 2. Now this case, it's going to be underneath, so it will be root x cubed underneath. So, or in our case, root 8 cubed. Okay, so here comes the fun now. So all we have to do now is somehow simplify these two. So how do we do this? So first things first, what I would personally do is pull out the side and just try and work out what root 8 is itself. So we should know that root 8 is composed of root 4 and root 2. And we know root 4 is actually the same as a whole number 2. This gives us an indication this is 2 root 2. Alright, that's done. Now how about root 8 cubed? Well, root 8 cubed is just literally 3 root 8 stacked together. So that's cubing it. And we know that when we multiply 2 root 8s, we get a whole number 8, and then we're left with root 8. We also know that root 8 is the same as 2 root 2. This means we're going to have 8 times 2 root 2, which is 16 root 2. Okay, done. Now, what happens here? Let's have a try. So now let's plug everything back in, yeah? Oh yeah, of course, we're going to have, what is it? 2 root 8. So 2 root 8 is just double 2 root 2, which is 4 root 2. So moving on. Substituting everything back in, we're going to have 1 over 4 root 2 minus, so 2 divided by this. This will give us 1 over 8 root 2. Nearly there. Now, the question, of course, wants us in the form of root 2. So what I would personally do is, firstly, let's tidy this up, and then what we need to do is rationalize. So only way to combine these two if they have the same denominator. We could just double these two. Why write it again? So make it 8 here and 2 there. So 2 take away 1 is just 1 over 8 root 2. Now here comes the fun, the rationalizing bit. To rationalize, we just have to multiply up and down by root 2 and root 2. This would give us what? 1 times root 2 is root 2, and then root 2 times root 2 is a whole number 2 times 8. 2 times 8 is 16, and hence we found our term. So it's 1 over 16 root 2. So this is just a simple case of recurring relationship. So this is sequences in series. So here they told you that a1 equals 1, and then you're given the relationship for an plus 1 in terms of an's. Now here for part A, they tell us to find the value of a2 and a3. Now let's have a crack. So to find a2, all we have to do, of course, is replace n of 1. So if n is 1 here, n is 1, and n is 1. So I have a1 over a1. We know a1 is 1, so bk 1 plus 1 over 1. Let's write it down. So replacing the values with a1 plus 1 over 1 again. This would just sum up to 2, so k times 2 is 2k over 1 is just 2k. So that's the easy initial step. And now let's find a3. A3 just telling us it occurs when n is 2. So we have a, 2 plus 1 is 3. So replacing these two with a2's, and we know a2 is 2k, so we have 2k here and 2k there. This gives us k bracket 2k plus 1 over 2k. Straightforward, right? Here we can cross simplify, so let's have a look. So we go k here, knock this out and this one out. This gives us 2k plus 1 over 2. Of course, you can leave like this, or you can go further and just, separate them. So 2k divided by 2 is just k plus, and a 1 divided by 2 is just half. So the answer would be k plus half. So either one, I believe, should be fine. Now, the second part, B, is another situation. Here we're given the fact that the summation from AR for R equals 1, 2, 3, in other words, the first 3 terms is equal to 10. And they want us to find the value of K. So, what do? Like they say, we find the first 3 terms, so we have A1 plus A2 plus A3 equals 10. Now, plugging in every single term here, so A1 is 1, A2 is 2k, and A3 is k plus half equals 10. That's it, guys. Dead easy algebra. So adding these k's up, we're going to get 3k. Adding these two up, we're going to get 1.5. 10 take away 1.5 is 8.5, or 8.5. And lastly, dividing across, and to make this easy for you, you should write 3k equals 17 over 2. That's what 8.5 is, between 17 and 18. Dividing by 3, you just times the bottom by 3, so 17 over 6. That's it, done. And I hope this helps. I think this was quite a nice question. It wasn't too bad. Question 4. So according to the exam paper May 2017 C1, we know there are companies producing 140 bikes each week. We know that the number of bikes produced increases by D each week until the company has produced 206 bikes in the 12th week. So here they would ask us, let's have a look, find the value of D. In other words, find the changing difference. Actually, in this case, find the difference per week. So pretty straightforward, nothing special here. So how do we do this one? So let's call this one part A. Okay, so we know firstly that this represents A, right? So we have A equals 140. And we know in week 12, U12, the number of bikes being produced is 206. Okay, so what happens here? So now using our general position equation, we've got UN equals A plus N minus 1D. All we have to do now is pretty much substitute everything. So to find the number D, we replace U12 here, replace A of 140 and replace N of 12, because that's we're at position 12. So if U12, we should have 206 on the left hand side equals 140 plus 12 take away 1 is 11 D. Now it's just a case of solving this, arithmetically. So take away, subtracting 140 should leave us with 66 equals 11D, and thus dividing by 11 should give us a difference of 6 per week. Okay, so notice that this only applies for between weeks 1 and 12, so we'll just put in a bracket weeks 1 through 12. Okay, let's move on to part B. Here we are, now part B. So after week 12, the company plans to make 206 bikes each week. Here they're asking us to find the total number of bikes in the first 52 weeks. Okay, so let's just understand this. So we know that after week 12 it caps at 206, and we know for the remainder period of the 52 weeks it will still be 206. So okay, alright, so let's have a shot at this. So our part B, we can say that the first change in difference, called it D1, has a difference of 6 between weeks 1 to 12. And then we know, of course, from week 13 there'll be no difference, it'll be locked at 206. So we say from weeks 13 to 52. So I like to plan my strategy before we actually get to it. So what does this mean? This means if we're going to find the sum of all 52 weeks, we take into account the sum of the first 12 weeks is here, plus, and we know this is locked at no difference, this means that it's locked at 206. And how many weeks is between here? Well, usually I just subtract them, and I subtract one more, you should get, actually subtract them, and then plus 1 to include the 13th week, and you should have a difference of 40 weeks. So we just simply say 40 times 206 because it's 40 lots of this amount. Now here we really just calculate S12. So what is S12? The formula is, in general, which we should know, is Sn equals n over 2, 2a plus n minus 1 times by d. We know what a is. A is 140, d is 6, and then n in this case is 12. So we're going to have 12 over 2 is 6. 2 times 140 is 280 plus 11 n minus 1 times d, so 11 times d, so it would be 11 times 6 would be 66. Okay, not bad. Now evaluating all of this, what happens? So this is actually not such a bad one. I've seen worse ones in earlier papers. 280 plus 66, so we can just add, what I do, just add 20. I mean, if you're not sure, if you're not confident of this, always try and increase value. So I'd raise this to add 20 to this one, subtract 20, and then it's just 346. Now multiplying this out, oh yeah, we can't forget this other term. Okay, so let's just put this over. So 40 times 206, again doing the same logic, 40 times 200 plus 40 times 6. So this part is not so bad. 4 times 2 is 8, block out 2 zeros, and then 40 times 6, again 4 times 6 is 24, adding a 0, so we should have 8, 2, 4, 0. Easy mental maths. Same for this one, but this is of course a lot tougher, so I'll do all of it at once. I mean, you can even do the standard way because this is not so bad to work with. 6 times 6 is 36, so put 3 up there. 4 times 6 is 24, plus 3, 7, 27. And 3 times 6 is 18, plus 2 is 20. So here we should of course get, let me put this back here, we should thus get 2076 plus 8240. And here we can just do the mental math, so we should have 8240 plus 2076. So again, this is nice. You should get 6 here, 4 and 7 is 11. This sums up to 3, and thus our final result would be 10,316 bikes. Man, this company is greedy. So, not so bad. After 1 year, they produced 10,316 bikes. Whew. Hope this helped, guys, and let me know for anything else. I'm moving on to number 5. Question 5. So here we're given a function that's given by x squared minus 8x plus 19. And now they want us to express this into this form. So if you remember, this form is known as completing the square. Okay, so let's have a shot at this. So now how to do this? Well, it's a very straightforward method. So let's do this, part A. All you really do is consider the first 2 parts and then half the second number, copy the rest, and then minus the square of that half number, and just wrap up in a bracket. So let's do this. So in this case, we're going to have x minus 4 all squared, copy the rest, and then minus the remaining square, which is minus 4 squared, which is 16. Collecting this up, and boom. I mean, this is actually pretty straightforward. Plus 3. Now, the main part of this question is the sketching part. So here we have to sketch the graph with the given points. So it tells us sketch this graph at point P when it crosses the y-axis, and sketch the graph at point Q with the turning points. From completing the square, we should know that the turning point is always the points here. So the turning point is given by the x-axis. So if it's in a bracket, it will be a positive x, so it will be 4. And of course, this is plus 3, so it will just be 3. This will be at point Q. At point P, when it crosses with the y-axis, all that means, let's have a go, is this point here. So crossing the y-axis, we should know that the intercept here is given right at the beginning, which is plus 19. And that's it. So we know it crosses at 0, 19. Oops. And this is point P. And that's literally it. So just plot it quickly. We should have, say this is 19. Let's say we go 4, I don't know, 3 here. We're going to make it so realistic. And then we just sketch a nice curve. And it should look like this. Remember, turning point is always the lowest point on the equation, which is here. So this is, again, 4, 3. That's it. So here they want us to find the distance PQ. And you go represent it into third form. So pretty straightforward, isn't it? So knowing the usual distance formula, so let's call this PQ. It's going to be, firstly, through the Pythagoras method, take the difference between the two coordinates. So let's say start x. So it'll be 4 take away 0, all squared, plus 3 take away 19, all squared, and then we have square root the whole thing. Now, just again simple math, so let's expand the bracket. So 4 take away nothing squared is 16, 3 take away 19 is minus 16, so minus 16 squared, it's pretty much, you can just start with, you can just work with 16 squared. If you don't know this one already, the easiest way to do this, 16 times 16, is firstly 16 times 10 and then 16 times 6. This one, 16 times 10 is 160. 16 times 6, well, another easy one I'll say is times it by 5 and then times it by 1. We know half of 160 is 80. 16 is just 16. Adding all these guys up, you can get 6. 16 plus 8 is 24. Plus 1 is 25. 256. Again, I mean, if you already know this, then definitely skip parts of this one. This is just all mental maths now. So final step, adding these two together should give us 16 plus 256 should be 272. Yeah, so again, mental maths. Let's break this into half. So halving this number, always work a half. So root 2, and this should give us 1 half of 72 is 36, root 136. Again, root 2. Half of 36 is 18 plus half of 100, 8, so it should be 68. Now it gets easier. So this is root 2, root 34, half of 34, 17. And then notice how many 2's we got. We got 1, 2, so these two make the whole number 2. These two make another whole number 2. And we're left with 2 times 2 is 4. 4 root 17, and thus guys, we should get 4 root 17. Done. Question 6. So here we're working with indices. And we're told that given that y equals 2 to the power x, so take note of this, we need to show that this equation results to this one here. We're going to get to part B in a second, and then of course part B we need to solve this one. So how do we do this? Well, firstly, let's look at the first term here. We know this one's obviously going to be y, we can see it. How do we make this 2y squared? We need to know our rules of indices. So let's look at part A. So from 2x plus 1, this can be rewritten as how? To form this is the multiplication of two numbers with the same base. So this is the same as 2 to the power 2x times 2 to the power 1. Because if you remember, a to the power of, say, 1 times a to the power 2 equals a to the power 1 plus 2, i.e. a to the 3. It's just a simple case, really, isn't it? So, what do we do here? So now we've done this, how do we separate this part? And again, if this is multiplied, another situation is that if you get a to the power x squared, this is the same as a to x. So you can see it's pretty much the reverse. So this is the same as 2 to the power x squared times 2. And substituting y back in, because we know that y equals 2x, we should get y squared times 2, or 2y squared. and thus replacing everything, it becomes quite clear that we're going to get 2y squared minus 17y plus 8 equals 0. Easy. So let's move on to the next part. We solved this, so now we presented this form, so now we want to solve it. How do we do this? So this is just a simple quadratic equation. My first guess would always do the factorizing method. So just do the double brackets with 2y and y here to make 2y squared. Now to get 8, the only combinations we really have is 8 and 1, 4 and 2. I'm not bagging on this one because we need to make a value, we need to make a big term in the beginning, so we need to make 17, and that's only done by adding, subtracting. So to get this term, I would say let's try 2 times 8 is 16 plus 1y would give us 17. So 2 times 8 is 16 here, so this has to be 1. To get plus a, we can do plus or minus minus, but minus minus makes sense to get negative 17. So negative 16, negative 1. And yeah, so let's work this out. So here this is going to give us 2y equals 1 or y equals half. This will give us y equals 8. And recall that y equals 2 to the power x. So this means we're going to get 2 to the power x equals a half. 2 to the power x equals 8. Now, rewrite this into bases of 2. So this is the same as 2 to the power x equals 2 to the power of negative 1. And this is 2 to the power x. 8 is the same as 2 cube. And hence, guys, this tells us that x here equals negative 1, x here equals 3. Done. Hope this helps. Number 7. So here we're given a curve C with equation y equals fx. And we're also given the derivative of this equation over here. So knowing that P lies on this curve C, we're asked to find an equation for tangent in this form. So what do we need to know firstly? First we need to know what the gradient M is, and we already know what X and Y is. That's given by this point. So we can substitute this in. But to get M is also found by this gradient equation. So we need to recall that the first derivative of a curve or anything is also known as the gradient equation. And we find it by plugging in the coordinate required to get the gradient at this point. So let's have a go at this. So for part A, we can say when x equals 4, in other words at point P, then we can find the gradient of P using this equation. So f prime 4 equals, then we just plug in 4 to this equation. 30 plus 6 minus 5 times 4 squared over the root of 4. Now this is just a case of solving. So the gradient M, what's it going to be? So this part, we got 5 times 4 squared. 4 squared is 16. 16 times 5 is 80. 6 take away 80 is minus 74. So let's do it so far. 30 plus minus 74 over square root of 4 is 2. Now simplifying this part, half of minus 74 is minus 37, and then adding it to 30 will give us minus 7. Good. And that's it. So now all we do is using this y equals mx plus c, the equation of a tangent, plug everything back in, the coordinate of p and the gradient. So we got minus 8 into it, so we can have minus 8 equals m, which is minus 7, x, which is 4, and then plus c. Do it so we can find the value c, rewrite this with m and c, and we're done. So what do we get? We know these two, minus 7 times 4 is minus 28. Plus it across, we're going to therefore get c equals 20. Hence, our equation of tangent is now y equals minus 7x plus 20. And that's it. This is the equation at the point, the equation of tangent at this point C. Okay, superb. So let's move on to part B. So here they just want us to find fx, i.e. the integral of this. Firstly, to integrate this, we need to rewrite this part into standard form. So let's do it. So rewriting this equation, we should get 30 plus, now I'll split this up. I'll do 6 over root x minus this term of root x. 6 over root x, we know root x is x to the power half. So just a keynote here. Root x is x to the power half. So therefore 6 over, if we're going to bring it back to the baseline, we're going to put a negative power, so it'll be 6x minus half minus 5, and again x squared over this, so it'll be x to the power 2 over x to the power half. When you're dividing powers, you end up dividing terms, you end up subtracting the power, so this would be 2 take away half, which is 3 over 2, and that's it. So we just really have to integrate this. So integrating this, we're going to have fx, which is the regular equation. Integral 30 is 30x. Integrating this term, so we're going to add the power, so it'll be a half, so it'll be 6 plus 6x to the power half, and divide it over this power. Same thing, repeat the process, 5x, add 1 to the power, you get 5 over 2, divided by 5 over 2, and of course plus c. Tidying this equation up, we should get 30x, 6 over half, so what we do is just do 6 times 2, which is 12, so it'll just be plus 12x to the power half. Again, same thing. These 5, so it'll be 5 times 2 is 10, 10 over 5 is 2. So it will be minus 2x to the power 5 over 2, and again plus c. And finally, rewriting this into the standard form, into its original form. X power half is just simply root x minus 2. Again, this is root x powered by 5, so it'll be root x powered by 5. Ooh, not bad. Now all we have to do is find out the value of c, and to do this, remember this c is not that c, so it ain't 20. So what we have to do is plug in these coordinates here, and then voila, we'll get c. So at point P, that means fx will be minus 8, so therefore we're going to have minus 8 equals, and plug it in 4 for all of this, we're going to have, so let's try this one, 30 times 4, which is 120, plus root 4, which is 2, 12 times 2 is 24, minus, okay, here we go, square root of 4 is 2, 2 to the power 5, so we can get 2, 4, 8, 16, 32. 32 double 32 is 64, and then plus c. Now we just pretty much summarize all this. So adding these two, you get 144, take away 64. Now I need to do this in my head. Just double checking again, so minus 8. So adding and minusing all this should give us 18, and just have to double check, plus c. And subtracting 80 across will give us minus 88. That's it. Now all we have to do is put this back into c, and then rewrite the whole equation. So therefore y equals 30, let me just bring it up a bit. Oh man. Y equals 30x plus 12 root x minus 2 root x to the power 5 minus 88. And that's it, guys. Hope this helps. So here, according to the statement, we know we have L1 has equation 5y equals 4x plus 10. Point P has x coordinate 5. So what I usually do these kind of equations, when you have an x coordinate already given, I will just substitute them straight in. So for example, knowing that this is 5, I'll just say P here has 5, and then the y we have to of course find out. We can just plug in this into either the L1 or L2 equation to find y. Next one, L2 is perpendicular to L1 and passes through point P. Yep, quite clear. L1, L2 cuts through the x-axis, again clear. So of course, the basic question is find an equation for L2 in the form of ax plus by plus c. So of course, using the straight line tangent equation, y equals mx plus c. If we know the gradient here, then we can gradient L1, and we could just find a perpendicular gradient for L2 and then plug in the x and y coordinate. So first things first, let's find the coordinate of y. Okay, let's do this. So I'll start here, so part A. So we can say at point P, which is 5 unknown, we can substitute this into 5y equals 4x plus 10. Replacing x with 5, we're going to have therefore 5y equals, well, 4 times 5, which is 20, plus 10. And of course this gives you 30, and then we're going to have 5y equals 30, hence dividing 30 by 5 will give us y equals 6. So therefore our coordinates for P is 5, 6. Straightforward. Now we need to find a gradient, and here we should know what the gradient is. All we do is just rearrange this equation and put into the form of y equals mx plus c. This will give us a gradient of this L1 equation. So rearranging this equation, so all you have to do is just divide by 5. So we have y equals 4 over 5x plus 2. Hence, the gradient of L1 is 4 over 5. And of course, since line L2 is perpendicular, we can say M2 is just, you multiply this by a negative sign and take the reciprocal. So you got minus 5 over 4. Lastly, to find the equation L2 now, all we have to do is simply using y equals mx plus c and replace it with our coordinates at P and our new gradient. So y is therefore going to be 6 equals m is minus 5 over 4, x is 5 plus c. Expanding this out, this will give us minus 25 over 4. So we're going to have 6 equals minus 25 over 4 plus c. Times everything by 4. We're going to have 24 equals minus 25 plus 4c. Plus and 25 across. We're going to have 49 equals 4c, and therefore c equals 49 over 4. Plugging everything back into the final equation to the mx plus c, we're just replacing m and c. We should have y equals m, which is minus 5 over 4, x plus 49 over 4. Because they want it in this original form, if you remember, into the form of ax plus by plus c, therefore all you have to do is just multiply 4 across. So we're going to have 4y equals minus 5x plus 49, and then putting everything on the left hand side, you're going to get 5x plus 4y minus 49. And voila guys, here is your equation of L2. Okay, let's move on to part B. Part B now. So what do we need to do? Here we need to calculate the area of triangle SPT. So just a quick recap. Okay, so I've attached the equation name for L1 and the equation for L2. I've also replaced the y coordinate 6 with the obtained, so P is now 5, 6. S and T, S crosses the y-axis and the x-axis, so of course we know that x-axis is the same as setting y to 0, and this is using the line L1. T, we use the line L2. So really we just need to use this equation, set y to 0 and find x for both. So quite straightforward, and the triangle SPT is just this shape here, which is in the vertical height and the base. Use the area of the triangle, boom, we have it. So without further ado, let's crack on. So at this stage, so let's work with S first here. So at point S, we're going to use the equation y equals 4x plus 10. So of course, we can find S when y equals 0. So when y equals 0, we therefore have 0 equals 4x plus 10. Rearranging this will give us, subtracting 10 and dividing by 4, will give us x equals minus 5 over 2. Easy. Again, let's do it at coordinate t. At coordinate t, we're going to use other equation, which is 5x plus 4y minus 49 equals 0. Again, setting y equals 0, we should have, let's have a think about this, we're going to have 5x minus 49 equals 0. Simple linear equation, so rearranging plus 49 divided by 5, immediately it tells us that x equals 49 over 5. Not difficult at all, is it guys? So now all we do is just sketch our triangle. So I'll just do a nice simple sketch. It doesn't have to be the best triangle ever. So we know that this is the coordinate P. Okay. So it's the coordinate P. Here we have S. We also have T. So here we know that the vertical height from P to the base. So remember this has coordinate minus 5 over 2, 0, 49 over 5, 0. So it's on that. So this is lying on the x-axis. So, and this is 5, 6. So because we know it's 5, 6, we know that it goes as high as 6. So the height is 6. Now the base is the difference between minus 5 over 2 and 49 over 5. So x-axis, so we're at minus 5 over 2. And we're finding the difference up to 49 over 5. So here you're literally just adding these two terms. Just what you could do, notice how we've got 2 and 5 in the denominator, just try and make them both over 10. So multiplying up and down by 5 should give us minus 25 over 10. Doubling this will give us 98 over 10. That's it. Terrible in 8. And now to find the difference, it would be 98 over 10 minus this, which is same as 98 plus 25. Adding these two should give us, if my maths is correct, 123 over 10. Don't think it's a hard maths. Just add 2 there and just take away 2. Okay. Not bad. Okay, so therefore, we can say that the area of triangle SPT equals 2, so half times base times height, so half times the base, which is 123 over 10. Some really crazy questions that Edexcel likes to give us. Times 6. Doing some cross simplifying, so crossing out 2 gives us 1, and 6 gives us 3. So now just 3 times 123. Thankfully, it's not a bad number. This should give us 369 over 10, which is which is exactly 36.9 units squared. I mean, I think this is fine anyway. You can leave it 369 over 10. But anyway, that's it, guys. Hope this helps, and I shall see you in the next question. Ciao. So in this equation, we are told to sketch on separate diagrams the graphs of y equals minus 3x plus c, where c is a positive constant and y equals 1 over x plus 5. So without further ado, let's go. So to sketch this linear graph, what I would personally draw, I'll draw a nice table here, call this x and y, and I'll just plot some values. So I'll always use when x is 0 and y is 0. Why? Because this shows you the points of intersection with the x and y axes. So when x is 0, what do we get? When this is 0, we're left with y equals c. And then another one, when y is 0, we're left with minus 3x plus c equals 0. So plusing 3x across and dividing by 3, we should get c over 3. Easy. So plotting this across, so this tells you when x is 0, y is c. And here, when y is 0, x is 3 over c. So let's just say 3 over c is here, for convenience sake. Okay, it doesn't have to be accurate. Then you just draw a straight line. Of course, do it with a ruler, not like this. Okay, that's it. Now for this one, this is just a case of drawing 1 over x and raising it up 5 levels. So suppose this was a typical inverse graph, which is 1 over x. To raise it 5 levels higher, we just have to think of the asymptote to be somewhere here. Suppose the asymptote is over here. Let's call this one 5. So this tells you that now, with this new asymptote, we should sketch the graph properly. So we're going to have something like this. And again, continue, and that's it. Of course, we need to see where it hits the x-axis, and we notice that it hits x-axis at this point here. In other words, when y equals 0, this is the same as x-axis line. So when y equals 0, what do we get? So matching this equation at y equals 0, we should have, of course, 0 equals 1 over x plus 5. Solving this, we can have minus 5 equals 1 over x, taking reciprocal, and thus x equals minus 1 over 5. So this coordinate here is minus 1 over 5. And that's it. So this is the asymptote, the point of intersection of the y-x-axis. So let's move on to part B now. Part B. So according to part B, we're given an equation, the same equation, and we know that where c is a positive constant, this equation meets the curve y equals 1 over x plus 5 at 2 distinct points. Now, what this means, two distinct points, this means we're looking at two real points. So in other words, we need to consider the discriminant. And this implies that because it's two real roots, we're gonna be using b squared minus 4ac, and it has to be greater than 0, because this implies that within the quadratic formula there has to be positive roots. If it's negative, then there's no roots. If it's single root, 1 point, then it'll be equal to 0. So let's try and produce it. So knowing that these two meet, this means that this equation equals this equation. So we're gonna have, in this case, 3x minus 3x plus c equals 1 over x plus 5. Now in this case, what you want to do is multiply x across to clear the fraction. So multiplying x, we're going to get minus 3x squared plus cx equals 1 plus 5x. Now now moving everything to one side to have a nice quadratic expression, we should have, so plussing across, we're going to have 0 equals 3x squared. 5x take away cx can be factorized as 5 take away cx, and then of course plus 1. Plus 1. And that's it. Now using the discriminant, calling this part your b, this 3 is your a, and c is your 1. Therefore, b squared minus 4ac should equal 5 minus c all squared minus 4 times 12 times 1. 4 times, somehow mentally solved it. 4 times 3 times 1 be bigger than 0. So of course this part is 12. So yeah, for some reason I was doing in my head the whole solution. So therefore we get 5 minus c squared greater than 12. That's it, guys. That's really it. Now let's move on to part C. For this part, now we need to find the range of possible values of c using the equation we just deduced. So just treat this as a equal sign, okay? Then pretty much we just need to solve the values of c and attach inequalities. So using the equal sign, I would say rewrite this as 5 minus c squared equals 12. So now square root on both sides, you get 5 again minus c equals plus minus square root 12. Here we could say square root 12 equals what? Well, breaking it down the third, we know 12 is made of 4 and 3, so root 4 and root 3, which root 4 is of course 2, so this is just 2 root 3. Easy. Now solving for c, plussing c across and subtracting this, we should get c equals 5 minus, well, plus minus actually, 2 root 3. So this is your points of intersection on the curve. Now another thing we can also do, we also need to find out where exactly it hits on the y-axis. So before we get there, let's just draw the function out. So we should have a curve a bit like this. So notice I obviously expanded on this side. It's because these solutions are positive. How do we know? Well, we should know that 2 root 3, root 3 is between 1 and 2 whole numbers. So imagine it was root 4, 2 times 2 would be 4, which is still less than 5. 5 to 4 would be on the positive. So let's just say this term here was 5 minus 2 root 3. And let's say here is 5 plus 2 root 3. So if we're going to sketch this nice curve, it looks something like this, and it cuts over here. Not the best curve, but pretty much where we're going. So what is this value here? Well, this is just the y-intercept, and this is found by pretty much expanding this fully. So let's expand this equation to find out what that value is. So 5 minus c squared equals 12. Expanding this, what do we get? So we should get 25 times 5 minus c, and then c minus 5 should give you minus 10c plus c squared equals 12. And now subtracting 12 across, we should get 13 minus 10c plus c squared equals 0. That's it. So when y equals 0, when the axis y-axis equals 0, we should get an intercept of 13. And this is our y-intercept. Lastly, the intervals now. So how do we know where the range of values are? Well, it tells you here. When the value is positive, in other words, greater sign, we always consider following the curve upwards. So we're looking at the end of when the curve is above the line, which is this part. So we can see it's right here. Also note that initially we know that C is positive. So this means it can only be up to here. And of course this goes on forever. So from 0 to this term. So therefore, because C is positive, we take this area and the rest of this term. So I should actually make it more clear. It's actually like this. That's it. And this goes all the way, guys. So our range of C values will be between 0 and 5 minus 2 root 3. So we say our interval is between this term, so C less than 5 minus 2 root 3, or C is bigger than this term, C greater than 5 plus 2 root 3. And that's it, guys. This is pretty much our inequalities. So let me know how it goes and see if you got the same result. So we're given a nice cubic curve where y equals fx and fx equals 2x minus 5 all squared times x plus 3. We are then given another expression, y equals fx minus k. So when something is minus k outside the function, it means we're going to be dropping it down, assuming k is positive. So we know we're going to find the value down going downwards, and it passes through the origin. So we know that this curve cuts through here, so we can say that this shape is now like this, cutting through this point. Okay, so here we have to find k. We're also given another curve, y equals fx plus c, and it has a minimum point at the origin. So we know we have to shift this to the left, and then we find out that the turning point is over there. So again, this will cut through, in some cases, the origin too. So without further ado, let's have a crack. So what I would do, I would always sketch the graph. So here we are, having a quick sketch. We should have this. So we know it drops a bit, so it dips. So this means the curve should be dipping over here. And again, we just continue drawing it across. So now at this stage, we can just call this graph y equals fx minus k. And the cool features about this one, because we know it cuts through the origin, we can just say it cuts through 0, 0. So replacing this with 0, we should have 0 equals f0 minus k. And we know what the function of fx is, don't we? It's given in the question. Fx, if you recall, is just simply this: 2x minus 5 squared times x plus 3. Okay, so now at this stage, what happens? Okay, so replacing x with 0, so we're going to have 0 equals this. Replace x with 0, we're going to have minus 5 squared times plus 3. So we're going to have minus 5 squared times 3 minus k. Evaluating this one, so this is going to give us minus 5 squared is plus 25. 25 times 3 is 75. And hence 75 minus k, so of course easily this is k equals 75. We are part 2. So now we need to sketch this curve. So we already know from the original equation that we got y equals fx, and now we know we're going to make a shift of c to the left, and this of course has a minimum point at origin. So this, in other words, the turning points here, one of them should have a minimum point. Of course, has to be this one because it's the lowest one, and has to be bending over here. So sketching it carefully should look something like this, and it bends over here. Good. So this is one turning point, and this is another turning point. This would probably be called the maximum point. This would be the minimum point. So we know because it's at the origin, we can replace xy with 0, 0. So you know at 0, 0, we therefore have 0 equals fc. So these are now 0. And we know what fc is pretty much fx at point c. So 0 equals, an equation now is going to be 2c minus 5 squared bracket c plus 3. Solving this would give us c equals 5 over 2 and c equals negative 3. Voila. And of course negative 3 is this one, 5 over 2 would be here. Hence the value we need is c equals 5 over 2, which represents the minimum. Okay, now let's move on to part B. He's asking us to show that f prime x equals this. In other words, the first derivative of a function must equal this. Not so bad really, it's just a case of expanding this properly. So let's have a shot. The majority marks expanding this, and differentiating is the easy part. So by expanding this, what do we get? Well, I always do the larger term first. In other words, to focus on one bracket, two brackets, and then do the next one. So because this is squared, this is straightforward. So let's expand the square. So we're going to have 2x times 2x is 4x squared. 2x times minus 5, and then minus 5 times 2x will give us minus 20x, or minus 10x, or minus 10x. Lastly, minus 5 times minus 5 is plus 25. We can wrap this firmly around x plus 3. Now I'm going to show you a cool trick when it comes to summarizing cubic equations. Okay, try to line them up by coefficients of x's here. I'll show what I mean here. So first let's expand it. So 4x squared times x is 4x cubed. 4x squared times 3 is plus 12x squared. And then lastly, minus 20x times x is minus 20x squared. Minus 20x plus times plus 3 is minus 60. And now 25 times x is plus 25x, don't forget x is here, I could have made a mistake, and 25 times 3 is plus 75. As you see, it's all laid down nicely by x's and by coefficients. Now all we want to do is pretty much sum these up. Okay, so summing all these up, because that's what we do. 4x cubed is of course 4x cubed. 12x squared minus 20 will give us minus, let me just double check this one. Yep, will give us minus 8x squared. 25 take away 60 is minus 35x, and of course we got 9x plus 75. Alright, so where are we now? So now we just have to differentiate this equation. Remember, this equals that. So taking the first derivative of this one, I think we can see we'll get it. So therefore, the first derivative equals, so in other words, to differentiate this, drop the powers down. So drop the power 3, and now 4 times 3 is 12x squared. Now it's getting so blurry, isn't it? It shouldn't be like that. And then then you got minus, drop the power 2, and 8 times 2 is 16x. And of course, differentiate minus 35, you get minus 35. Plus 75 disappears, and voila. Here is the answer to part B. Let's move on to part 10C. So we know that given that A and B are distinct points that lie on the curve y equals fx, we got 2 points, both real. So there's not too much to worry about. The second statement is important. The gradient of y equals fx, the curve at A, is equal to the gradient of the curve at B. From this statement alone, we need to deduce that the gradient for, let's say, at point A is equal to the gradient at point B. And just recall that the gradient comes from the first derivative of the curve itself, so we're going to stick with this function here. Okay, so this will probably be key to give us what we need. Okay, so this is of course the gradient equation. We also know that given that A has x coordinate 3, find x coordinate B. Okay, so literally we know that because these two have the same gradient, put into this equation we should have a pair of solutions that satisfy. One of them giving us a solution of 3, and another one giving us a solution of B. Quite straightforward, I think. So replacing the gradient equation with the value of x equals 3, what should we get? And of course this is the gradient itself. So what happens here? When x equals 3, we can use the gradient of MA, which is 12 times 3 squared minus 16 times 3 minus 35. So evaluating this, what do we get? 12 times, so this is 9, so 12 times 9 here will give us 108, minus 16 times 3 is 48, minus 35. So now our quick mental math skills, 108 take away 48 should be 60, 60 take away 35 is 25, and voila, here's our gradient. Not bad, is it? So what do we do here now? So now that we've got a gradient here, what we could do is find a gradient, find the x-coordinate b, and to do that we have to plug this back into the equation and solve this quadratic. So to find the x-coordinates now, again, plugging this into the gradient expression, we're going to have 25 equals 12x squared minus 16x minus 35. So the logic behind this is that when you solve this expression, we get two x-coordinates. One will give you a solution of 3, and the other one will give you a solution of b. Subtracting 25 will give us 12x squared minus 16x. Minus 35 take away 25 is minus 60. Now, factorizing, but before you factorize, let's try and simplify this. We know that they all go into 4, so we can divide the whole thing by 4. So dividing by 4, we should have 3x squared minus 4x minus 15. Not bad. Now just a case of factorizing it properly. We've got 3x squared, so we know one's going to be 3x and x. To get 15, we know because one solution is 3, my money is that 3 is over here. So 3, and I know 3 and 5 make 15, so putting 3 here and 5 here, we can see that 3x times 3 is 9x. So we can do minus 9x plus 5x will give us a minus 1, so minus 9x. We need a solution of 3. Of course, this must be plus. And hence, looking at this, we know we've got our x coordinate here, our x coordinate for A, and then our x coordinate for B is therefore minus 5 over 3. Easy guys, easy guys. So I hope this helps, and let me know in the comments or anything if you have any more questions. I'll be doing the C2 paper too, so see you all for now. Ciao.